Here in this problem, we're dealing with marbles in a bag, but the most important thing here as you read through the problem is this, let me highlight this in yellow, randomly choosing two marbles one at a time. So that's the key, one at a time, and without replacements is important as well. But the fact that we're looking at the probability of a sequence of two things happening one after another, this tells us that we're using the multiplication rule of probability. Now, this is basically the probabilistic equivalent of the fundamental counting rule. So remember, with the fundamental counting rule, we're counting, we're breaking our counting process up into a sequence of steps. Here we're calculating an actual probability, and we're calculating that probability as a sequence of events that happen one after another. I've drawn this tree diagram listing the all possible sequences of events, but this is definitely not necessary. It's just, it's helpful in the explanation. So, part one, what's the probability that the first marble is red and the second marble is blue? All right, so if we follow this tree diagram that I have listed. First marble is red, second marble is blue. Okay, so that only happens one way, one specific way. Now, we have, say, 9 red, 8 white, and 6 blue. So there's 23 marbles in total. So let's break it up into step by step. The probability that the first marble is red, well, there's 9 red marbles out of 23 total marbles. So our chances of getting a red in that first step is 9 out of 23. And now, the second marble being blue, well, there are 6 blue marbles, but be careful here, there are only 22 marbles left. So this is actually also a situation where we're considering conditional probabilities. So informally, and I think informally is a better way of looking at conditional probability, all that means is you have to update the numbers that you're using at each step in a sequence. Step 1, we had a total of 23 possible outcomes, and in step 2, we have a total of only 22 possible outcomes. So this two-step sequence has a probability of, let's see, 9 times 6 is 54, and on the bottom, 22, let me just take out my calculator, 22 times 23 is 506. Now we probably want to reduce that. Let me actually open up that calculator. 54 divided by 506. So we could use a decimal round, so the directions say round to 3 decimal places, or if we want to get a fraction, if we use the calculator to convert this back to a fraction, it'll give us in simplest form. So 27 out of 253. Okay, so that sounds good for, excuse me, for the first problem. Now, in part 2, the probability that they're both the same color. Okay, well, if you look over here at the tree, that could happen multiple ways. So we could have two reds in a row. That's one option. We could have a white, then a white. That's option 2. We could have a blue, then a blue. Option 3. So we have to look at each one of these individually. So let's start with red then red. What's the probability that happens? And let me come over here. So probability that the first marble is red, well, that's again 9 out of 23. And the probability that the following marble, or the second marble, is also red, well, now there's 8 reds left out of 22 total. So 9 times 8, that's 72 on top, and the 23 times 22, that's again 506. Okay, so 72 out of 506, that's the probability just of 2 reds. Now if we look at the second case, 2 whites, well, there are 8 white marbles, so the probability first marble is white, you have an 8 in 23 chance. And then once that one marble's gone, remember, we're going without replacement. this is where the conditional probability comes into play. The condition that the first marble is white tells us there are only 7 whites left out of 22 total. So that'll give us 56 out of 506. And now the third possible case, 2 blues. Well, probability the first marble is blue. There's 6 blues out of a total of 23. And at the second step, there are 5 blues left out of 22 in total. So that will be 30 out of 506. So we have probability of 2 reds, probability of 2 whites, or probability of 2 blues. And we could add these up. So that looks like, let me come back over here. The 72, 56, and 30 should add up to, looks like 158 out of 506. So let's reduce that. $158 divided by 506, and we'll turn that back to a fraction. 79 out of 253. And part 3, it looks like we have the same scenario. The specifics are different, but we have the same scenario. There's 3 ways this could happen. What's the probability the second marble is blue? Well, let me erase that, and let me erase that. And it looks like the second marble being blue could happen this way, so red-blue. It can happen this way, white-blue, or it could happen on the bottom, blue-blue. So basically, what I have here in red on the right-hand side, we just need to change some of those numbers. And I'm not going to have room to write it all down, but the probability the second marble is blue. So the first scenario, red-blue, well, let's see, there are 9 reds out of 23. And there are, at step 2, there are 6 blues out of the 22 remaining marbles. All right, so that product will give you the probability of just red-blue. Now we need anything followed by a blue marble. So next, we'll bring in the probability of a white and then a blue. So there's 8 white marbles out of the 23. And then following the white, if the second marble is blue, there's now 6 blue marbles out of the 22 remaining marbles. And finally, a blue followed by a blue. So first marble, probability it's blue. There are 6 blues out of 23. And at step 2, we've got 5 blues left out of 22 marbles. So this calculation should give us the probability that the second marble is blue. So let's see, that looks like, well, we know the bottom is 506, so 54 plus 48 plus 30. Oh, this we don't need. So 54, 48, 30, so that's 132 out of 506, and then pop that into the calculator. We could reduce that. Looks like 67 over 253, but double check that with the calculator. Okay, so that does it here. The difference between part 1 versus parts 2 and 3. Part 1, we're looking at the specific case red then blue. Happens only one way. But in part 2 and part 3, each of these, 2 of the same color or second marble is blue, each of these 2 can be done in 3 different ways. So that's why we calculate the 3 separate probabilities and add them up. So there's a lot of individual rules of probability going on here. We have the addition rule of probability between the individual cases. We have the multiplication rule of probability dealing with the steps within each case, and we have the fundamental counting rule sort of within our calculations of probability. And then the last thing we need to consider is conditional probabilities. And again, that's just at each step in a sequence of events, you have to update the current numbers based on what has previously happened. That's why in each of these products, the second fraction is divided by 22, not by 23. All right, that does it for this one.